The valves have to face constant, rapid opening and closing. With a cam-to-crankshaft ratio of 1/2 to 1, the exhaust and intake valves open once for every 2 revolutions of the crankshaft. At a top no-load speed of 3,600 RPM, the valves open and close 1,800 times per minute. Likewise, the valves endure temperatures of 600 to 800 degrees Fahrenheit for the intake valve and nearly 1,400 degrees for the exhaust valve. The most common valve failure that affects compression is the seal formed by the valve face contact with the valve seat. So, how does that happen? Well, let's start at the top of the valve stem and work our way down. That's the top for overhead valve engines, or if you prefer, the bottom for L-head engines. First, insufficient valve clearance, or valve lash, can be a cause of low power by preventing a valve from closing all the way. For overhead valve engines, valve lash is measured between the rocker arm and the valve stem, while for L-head engines, valve lash is the clearance between the end of the stem and the tappet. A partially open valve will allow compression pressures to escape. And remember that heat can cause the valve stem to grow. What is sufficient valve clearance at low temperature may become insufficient valve clearance at high temperature. In addition, the exhaust valve is cooled by its contact with the seat. If the valve overheats, the valve face and the valve seat will pit, erode, and burn. Next, valve guide wear can cause the valve face to not seat. This type of wear is normal over time and should always be considered when working on an engine with high operating hours. The rocking motion of the rocker arm or the cam lobe on the valve stem is a diagonal pressure that wears on the valve guide. The more wear, the greater the angle of the valve in its guide. The greater the angle of the valve stem, the less the valve face seats squarely on the valve seat. Once again, the valve would not seat properly, causing a loss of performance. But because of the valve's inability to dissipate heat into the valve seat, once again the valve failure will be caused by the overheating. The valve spring can also affect valve stem angle if the spring is not parallel to the valve stem. Valve spring parallelism should always be checked after installing the valve retainers. Exhaust valve guides are subject to wear from carbon chips found in exhaust gases. Worn intake valve guides and/or seals, normally an area of boundary lubrication, could allow excess oil into the combustion chamber. Exhaust valve guides generally do not have this problem because of a lack of vacuum. The exhaust valve also faces the additional problem of its higher operating temperatures. Any condition that increases operational temperatures, like plugged cooling fins or heavy load, may overheat the exhaust valve and make it soft enough for the seat to leave an impression on the valve face, reducing valve sealing. If a piece of carbon or combustion deposit were to become lodged between a valve face and the valve seat, this would cause a loss of engine performance. But, more importantly, this would prevent the valve from dissipating heat into the valve seat, causing the valve to overheat, leading to a valve failure. And finally, if we don't have sufficient valve tappet clearance, or if the seat were cut improperly, again, we will experience performance loss, but the actual failure will be caused by the overheating of the valve or its inability to cool itself properly. Next in order, let's consider the valve seat. The valve seat can be damaged from other conditions as well. Debris, usually carbon chips, and/or the effect of corrosive chemicals formed during combustion, can damage the seats. The angle of the seat is even worth considering when analyzing the valve face to seat seal. Briggs & Stratton exhaust valves have a 45-degree angle. The steep angle helps to grind up any debris between the valve face and the seat. Some intake valves have a 30-degree seat angle. At this angle, it's easier for debris to get caught between the valve face and seat. Another design feature of both exhaust and intake valves that affects the seat seal is valve rotation. Too little rotation or lack of rotation can cause buildup on the exhaust seat, which may result in overheating, while too much rotation can cause accelerated wear. The lack of rotation can be caused by deposits in the valve guide and by improper techniques when adjusting the valve clearance. On L-head engines, the valve stem must be ground at a 90-degree angle. It's real easy, using a grinding wheel, to get the angle wrong or to end up with a high spot on the stem that will affect rotation. You can see that proper service of the valve train is important to the seal of the valve face to the seat. Any minute deviation in angles or contact faces can have an effect on the life of the engine.